Okay, so I'm going to go over the review sheet with you guys. And number 1 says to solve the equation 2x to the third minus x squared minus 8x plus 4 equals 0 algebraically for all values of x. So you have to think factor, grouping, quadratic formula, complete the square. So what you should notice right away is that there are 4 terms here. And that when there are 4 terms, that you want to solve this by grouping. So let me write this down. So we have 2x to the third minus x squared minus 8x plus 4 is equal to 0. So I see that there are 4 terms, so I'm going to start by grouping. So I group the first 2, and I group the second 2 here. So now I'm going to use the GCF for the first group, and I notice that the GCF is x squared. So I factor out the x squared, and I get 2x minus 1. I notice that in the second group I have a negative right here, so I'm going to bring that out. And my GCF is 4, and then I get 2x minus 1. So my coefficients, the x squared and the negative 4, that is one factor, x squared minus 4. And my other factor, which is the double parentheses, is 2x minus 1, and that equals 0. So now I notice that inside this parentheses here, that is the difference of 2 perfect squares. So I'm going to factor that, x plus 2, x minus 2, and I still have 2x minus 1 equals 0. So now that it's all factored, I make my t-chart, and I set each one equal to 0. And I'm going to solve. Minus 2, x equals negative 2. Add 2, x is equal to 2. Add 1. 2x is equal to 1. Divide by 2. X is equal to 1/2. So those are negative 2, 1/2, and 2 are my roots. They're my zeros. It's where it crosses the x-axis for the graph. Okay, so let's take a look at number 2. We want to solve algebraically. So again, I see that it's not equal to 0, first of all. And I want to take that equation, and I'm going to set it equal to 0. So first, let me write it down. X to the third plus 5x squared equals 9x plus 45. So I first want to set it equal to 0. So I'm going to minus 9x. That does not match up with anything on this side of the equation. And I want to minus 45. And again, that also does not match up with anything on this side of the equation. So I get x squared, put it x to the third, sorry, plus 5x squared minus 9x minus 45 is equal to 0. So I see that it is 4 terms. I am going to factor by grouping. I group the first 2, and I will group the last 2. And I notice that the GCF of the first 2 is x squared, and I get x plus 5. And there's a minus here, so I bring out the minus. GCF is 9 times x plus 5. So my factors are x squared minus 9 and x plus 5. And then notice, again, in this problem, I have the difference of 2 perfect squares. So I get x plus 3, x minus 3, and x plus 5 equals 0. T-chart, set them equal to 0. And then we'll solve. Minus 3, x equals negative 3, plus 3, x equals 3, minus 5, x equals negative 5. So those are my roots. Negative 5, negative 3, and 3. Yes, that is a 3 there. Negative 3 and 3. Those are my roots. Those are my zeros. All right, so number 3 says find the difference. Difference means to subtract when 7 over 8x squared minus 3/4 x is subtracted from, so we're subtracting from this guy, 5x squared minus 1/4 x plus 2. So the from, that will come first. I'm going to set it up in parentheses. All right, so in the first parentheses, I'll have 5/8 x squared minus 1/4 x plus 2 minus 7/8 x squared minus 3/4 x. All right, so I am subtracting. Remember, there's a -1 here, so you want to distribute the -1. There's actually 1 here, so we'll distribute the 1. So when we distribute the 1, for the first parentheses, we get the same thing. 5/8 x squared minus 1/4 x plus 2. Now distribute the -1, we get -7/8 x squared plus 3/4 x. Now I want to combine like terms. So you could use your calculator for the fractions if you need to. But I have 5/8 x squared, -7/8 x squared. But you should recall that when we add or subtract fractions, we need the same denominators, and I do. They're both 8. So I will add or subtract the numerators and keep the denominator. So I have here 5 minus 7 is -2 over 8x squared, which actually becomes -1/4 x squared. All right, and I also have here my x's, -1/4 x, positive 3/4 x. So again, the denominators are the same. You guys are lucky. And I will take care of the numerators. -1 plus 3. -1 plus 3 is positive 2. So that would be positive 2 over 4. Keep the denominator, x. And that actually becomes 1/2 x. And then I have this guy right here, this plus 2, but there's no number to combine it with on the other side. So I'll just put plus 2 at the end. So that's my final answer. Okay, so number 4, it says to simplify. So I had this multiplication of these two binomials. Notice they are conjugates. Look at the sign in the middle is different. And I am adding it to this guy right here, x minus 1 squared. Now, in order to add this to this, you're going to have to multiply first, because that's what PEMDAS says to do, is to multiply. And this here is a multiplication. That's x minus 1 squared is x minus 1 times x minus 1. All right, so let's write that down. So we have 3 has x plus 1 times 3 has x minus 1 plus, and then I have x minus 1 squared. Now, x minus 1 squared means to do x minus 1 times x minus 1. All right, so I'm going to take care of the left side over here first. I'm going to double distribute. You could use your calculator, but when you multiply fractions, you multiply the numerators, you multiply the denominators. So 3 halves times 3 halves would be 9/4 x squared. 3 halves times -1 is -3 halves x. 1 times 3 halves x is positive 3 halves x. And 1 times -1 is -1. So notice that these terms right here, they cancel out because they're opposites. So I have 9/4 x squared minus 1. All right, let's work on the other side over here. I'm going to double distribute. X times x is x squared. X times -1 is -1x. -1 times x is -1x, and -1 times -1 is positive 1. Combine like terms, I get x squared minus 2x plus 1. Now, since I'm adding, all I have to do right now is combine like terms. All right, so I have here 9/4 x squared and 1x squared. So when I add 9/4 x squared with 1x squared, right, because remember there's really 1 there, you can use your calculators, or this is really 4 over 4 to make the same denominators. That's 13/4 x squared, but use your calculator, you can check that. I have here a -2x, but there's no x over here on this side, so that's just minus 2x. And then notice I have a -1 and a positive 1, so those will actually cancel. So this would be my final answer. Okay, so let's take a look at number 5. It says to find this here. That notation, that -1, that means the inverse of this right here. So inverse means to switch x and y. So I have this function, f of x, is equal to 2x to the third minus 5. So I want to switch x and y. That's what this means here, f to the -1x. That means inverse. And inverse means to switch x and y. All right, but where is my y value over here? I don't see a y value. Well, f of x is another way just to write y equals when we're representing a function. So I have y equals 2x to the third minus 5. Now I can switch x and y. X equals 2y to the third minus 5. Now I want to put it in y equals form. So I'm going to add 5. X plus 5 equals 2y to the third. Divide both sides by 2. X plus 5 over 2 is equal to y to the third. Now, how do we get rid of a third? The third power, we take the third root of both sides, the cube root. So those they cancel each other out. So I get y is equal to the cube root of x plus 5 all over 2. And I want to write it using inverse notation. So that's the inverse of f of x is equal to the cube root of x plus 5 all over 2. Okay, so let's take a look at number 6 here. It says to determine the nature of the roots. The nature of the roots means to tell what type of roots you're going to have. It's the discriminant. Are the roots going to be real, rational, equal, real, rational, unequal, real, irrational, unequal, or are they going to be imaginary? And in order to figure that out, I am going to use the discriminant. So hopefully you recall the discriminant is what's underneath the radical. It's what's under the radical of the quadratic formula. So that's b squared minus 4ac. Just knowing that number tells me what kind of roots we will have. So let's take a look at the first one. We have 2x to the second minus 3x minus 5 is equal to 0. So a is equal to 2, b is equal to -3, and c is equal to -5. So I'm going to plug it into the formula. So I have -3 squared minus 4 times 2 times -5. And you can plug that all into your calculator all at one time. Just make sure you use parentheses around the b value that you're squaring since it's a negative. And we get a discriminant of 49. So now you want to say to yourself, all right, so I have this, think of the quadratic formula. I'm pointing to my head while I'm saying that. Think of the quadratic formula, right? Quadratic formula, some number plus minus the square root of 49 over some number. Are my roots going to be real? Yes, if you could take the square root of this number, they're going to be real. So they are real. Real meaning that it's on the number line. Now you're going to say to yourself, is it rational or irrational? If you can take the square root of this number, then that's a rational number. Right? The square root of 49 is 7. And will they be equal or unequal? So remember, I just said you could take the square root of 49. It's 7. So think about it. You have a number plus 7, a number minus 7. You're going to get two different numbers. Those are going to be unequal. So my roots are real, rational, and they are unequal. All right, so the next one, let me get rid of this here. I just got rid of my discriminant. B squared minus 4ac, the discriminant. My next one is x squared minus 2x is equal to -1. So the first thing you want to do is you want to set it equal to 0, so add 1. X squared minus 2x plus 1 is equal to 0. So a is 1, b is -2, and c is 1. So I get -2 squared minus 4 times 1 times 1. And again, you could just plug this into the calculator and you get 0. So think of the quadratic formula, number plus minus the square root of 0 all over a number. So you start saying to yourself, is it real? Can you take the square root of 0? Yes, that is real. Rational or irrational. If you could take the square root of 0, which you can, it's 0. That is a rational number. All right, now you're going to say to yourself, I have a number plus 0, a number minus 0. You actually get the same exact number because you're adding and subtracting 0 from the same number. That means they are equal. All right, let's get rid of that. Okay, and the discriminant, b squared minus 4ac again. The next one is 2x squared minus x plus 6 is equal to 0. A is 2, b is negative 1, and c is 6. So I have negative 1 squared minus 4 times 2 times 6. Just plug it all into the calculator all at one time. I get negative 47. Think of it, number plus minus the square root of negative 47 all over number. This one's easy because when you have a negative underneath the radical, that is imaginary. They are not real. They are not on the number line. Okay, so number 7, A and B is to factor completely. So I'm starting off with m to the third minus 125. So I noticed right away that I only have 2 terms here. So I either have to think of possibly greatest common factor, but it's not the greatest common factor. There's nothing in common to both terms. I could think difference of 2 perfect squares, but I have an x to the third, so that's not a perfect square. Or I have to think sum or difference of 2 perfect cubes. So m to the third is a perfect cube, and also 125 is a perfect cube. So remember we did SOAP? That's what I want to think of. Set up your 2 parentheses. I get the same sign, which is negative, opposite sign positive, and always positive at the end. What is the cube root of m to the third? That is m. And the cube root of 125 is equal to 5. So remember, inside your parentheses, this is a, b, this is a squared. Down here is b squared, and in the middle is a times b. This would be your a, this would be your b. So it's m minus 5. M squared, 5m in the middle, and then I have 5 squared, the b squared. 5 squared goes right over here. B squared, that's 25. So that's my answer, and that's factored completely. All right, so let's take a look at the next one, which is 3a to the third minus 81. So again, I have 2 terms, so I have to start thinking, is there a GCF? And yes, there is a GCF. 3 is the GCF. 3 does go into 81. So I have 3 times a to the third minus 27. So now I still have 2 terms. So now I want to think difference of 2 perfect squares? No, because I have an x to the third and 27 is not a perfect square. Or is it the difference of 2 perfect cubes? Yes, a to the third is a perfect cube, and so is 27. So remember SOAP. So I have 2 parentheses. It's same, opposite, always positive. The cube root of a to the third is a. And the cube root of 27 is equal to 3. So inside my parentheses would be a minus 3, a squared, 3a, and 3 squared, which goes back there, is 9. So that's my final answer. Okay, so number 8 is to simplify your i's. So there are 4 i's that you need to know. You need to know I to the 0, which is 1. I to the first is I squared is negative 1, and I to the third is negative I. Those 4 you need to know. So let's do I to the 31. So I to the 31, you can plug that into your calculator, do I part, and then you type in I carry key 31. So I to the 31 gives you negative I. All right, now we want to do I to the 50. So you type in I part, I carry key 50, and we get I to the 50 is equal to negative 1. I to the 41, you do I part, I carry key 41, and we get I to the 41 is equal to I. And the last one is I to the 32. I part, I to the 32. I to the 32 is equal to 1. Okay, so we are on to number 9, which is the word problem. So the arch of an aluminum frame door can be represented by the function y equals negative x squared plus 20x minus 91, where x and y are measured in feet. Put this equation in vertex form. So let's start with that. So I want to group the x's, which are already grouped, and move the constant to the other side. So actually what I'm going to do is I'm going to move this to the other side so I can get my x squared to be positive, and then I'll move the y over there. So I get x squared minus 20x equals negative y minus 91. Now I want to complete the square only for the x's. So half of negative 20 is negative 10. Squared is 100 added to both sides. So I get x squared minus 20x plus 100 equals negative y minus 91 plus 100. I'll simplify the right side. I get negative y plus 9. And over here I'm going to factor this. I get x minus 10, x minus 10, which is x minus 10 squared equals negative y plus 9. Now notice that this is not in the right form because I have that negative in front of the y, so I have to factor that out. So x minus 10 squared, the GCF is negative 1, times y minus 9. Okay, so it says to find the highest point on the door. So if I just take a look at my parabola, just draw a quick sketch of a parabola here. Right, so I have this parabola. I'm looking, this is my door. I'm looking for the highest point on the door. So that's actually my vertex. So identify the vertex, and that is 10, 9. So my x value here is 10, right? So this is 10, 9. And my y value here is 9. So remember, my x and y are in feet. So that means my highest point is 9 feet for the highest point. All right, so the next thing it says to do is to see how wide the arch is at the bottom. So I want to look how wide it is from here to there. So I need to find these numbers. Then I can just count the boxes. These numbers, remember, are your zeros. They're your roots. All right, so I have to actually see if I could factor this and find the roots. So let me move this around here a little bit. All right, so here's my equation, just rewriting it. Okay, so I have y equals negative x squared plus 20x minus 91. So now I'm looking for my roots. That means my y value has to equal 0. So I have 0 is equal to negative x squared plus 20x minus 91. All right, so I notice that I have a negative in as my leading coefficient. I want to get rid of that, so I'm going to divide everything by negative 1. So I get 0 equals x squared minus 20x, and then I have plus 90. All right, so now I'm going to see if I can factor this. So I multiply the first times the last, I get, 90 again. So I'm going to multiply the first times the last, and I get positive 91x squared. 91x squared. Now, are there numbers that multiply to 91 and then add to negative 20? Yes, that's negative 13x and negative 7x. So bring down the 91, bring down the x squared. And now I'm going to factor by grouping. All right, so the GCF is x times x minus 13. GCF is negative 7 times x minus 13. So my factors are x minus 7 and x minus 13, and that equals 0. I make my t-chart. Set them equals 0. I get x is equal to positive 7 and x is equal to positive 13. So those are my roots. That's these numbers right here, 7 and 13. So now I want the distance from 7 to 13. So 13 minus 7 is 6. So the width of the door, of the arch, is 6 feet wide. Okay, so number 10 is to write the equation given the zeros, given the roots. All right, so I'm actually going to start with 10b first because 10b is easier than the 10a. So my roots are -3 and 3. So I'm going to set them equal to x. I'm going to now set them equal to 0, so add 3. X plus 3 equals 0, minus 3. X minus 3 is equal to 0. Now I'm going to set them up as factors. X plus 3 times x minus 3, and that equals 0. Now I'm going to double distribute. X times x is x squared. X times -3 is -3x. 3 times x is 3x, and -3 times 3 is -9. So clean it up here in the middle. They cancel out. That always happens when we multiply conjugates. So I don't know if you guys noticed that they're conjugates. So I get x squared minus 9 is equal to 0. Remember to represent it as a function. F of x is equal to x squared minus 9. All right, and now 10a. Okay, those other roots. 5, negative the square root of 6, and the square root of 6. So before I do this, I just want to point this out, that if you're given roots as, let's say, 5 and negative the square root of 6, one of the things you guys need to realize is that this is actually coming from the quadratic formula or complete in the square, and that if you're given the roots just like this, you have to know that there is another root that goes with this guy, and that is the positive square root of 6. So you have to know that, so remember that. Okay, so little hint, okay? So let's set each one equal to x. Equal to 0, minus 5. X minus 5 is equal to 0. Add the square root of 6. X plus the square root of 6 equals 0, minus the square root of 6. X minus the square root of 6 is equal to 0. All right, so I set them up as factors, x minus 5, x plus the square root of 6, x minus the square root of 6. All right, so notice these two here. They are conjugates. Notice that the sign in the middle is different. So I'm actually going to multiply those first. Okay, because when we multiply conjugates, you always get something special. So I want to start with that. X times x is x squared. X times negative the square root of 6 is negative x the square root of 6. The square root of 6 times x is x the square root of 6. The square root of 6 times negative the square root of 6 is negative the square root of 36. So notice here in the middle, they're opposites, so they will cancel out. That always happens with conjugates. So I get x squared minus, this becomes 6. And now I'm going to multiply that by x minus 5. All right, so I have x times x squared is x to the third. X times negative 6 is negative 6x. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 6 is positive 30. I'm just going to clean this up here, put it in the right order. I get x to the third minus 6. Nope, the 5x squared should come first. Minus 5x squared minus 6x plus 30, and that equals f of x. Okay, so number 11 says to find the equation for the parabola given the following information. So this is 11a. They give us the focus is -3, 3. And they give us the directrix is y is equal to -1. All right, so let's draw a picture here. I have -3, 3. So there's my focus, and my directrix is -1. Y equals -1. It's right down here. Okay, so what I want, this is my directrix, is I need to find the vertex, because remember the equation for a parabola is x minus h squared is equal to 4k times y minus p. All right, so I'm looking for hk now. That's the vertex. Now remember, the vertex is someplace in between your focus and the directrix. It's right in the middle, so you have to find what the distance is from focus to directrix. So count the boxes, 1, 2, 3, 4. half of 4 is 2. So I'm going to count 2 boxes, 1, 2. So there's my vertex, and my vertex is negative 3, 1. All right, there's my HK. So I have x, remember change the sign, plus 3 squared is equal to 4p times y minus 1. Now what I need is my p-value. Remember, p is the distance from vertex to focus. And since it's moving up, my p is positive, and it's up 2, positive 2. So it's x plus 3 squared is equal to 4 times 2 times y minus 1. Just have to multiply the 4 times 2. X plus 3 squared is equal to 8 times y minus 1. All right, and now let's do 11b. So 11b is they give us the focus, which is 7, 2, and they give us the vertex, which is 7, 6. All right, so let's draw a picture here. All right, so I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. It's 2 and 6 here. And 7, 2 is my focus, and my vertex is 7, 6. So here's my equation, x minus h squared is equal to 4p times y minus k. So I actually have hk, that's my vertex. So just remember to plug it in opposite sign. So it's x minus 7 squared equals 4p times y minus 6. Now I need the p-value. Remember, p is the distance from vertex to focus. Since I'm moving down, my p is going to be negative. It's moving down 4 units, so it's negative 4. So x minus 7 squared is equal to 4 times negative 4 times y minus 6. So x minus 7 squared is equal to negative 16 times y minus 6. Okay, so we are on the last problem, number 12. It says put the equation in vertex form, find the vertex, focus, and directrix. So we have x squared minus 8x minus 4 plus 2y is equal to 0. All right, so my x's are already grouped together, and I want to take the constant and the y, move it to the other side. So I have x squared minus 8x is equal to negative 2y when I minus 2y, and add 4, I get positive 4. Now I want to complete the square for the x's, so I do half of negative 8 is negative 4. Squared is 16. I'm going to add it over to this side. X squared minus 8x plus 16 is equal to negative 2y plus 4 plus 16. Just clean up this side here. We have negative 2y plus 20. And I'm going to factor this x minus 4 times x minus 4, which is x minus 4 squared. And then over here on the right side, I have to make my y have a leading coefficient of 1. It's negative 2. So I have to factor out the negative 2 times y minus 10. All right, so I'll identify my vertex. My vertex is 4, 10. And I'll draw a picture here. So I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 9 and there's 11. So I have 4, 10, which is right here. That's my vertex. All right, so now I need to get my focus and my directrix. So this guy here, this negative 2, remember that's your 4p value. So 4p is equal to negative 2. So p is equal to negative 2 over 4, which is negative 1/2. All right, so remember, p is the distance from vertex to focus. So since it's a negative 1/2, that means my focus from my vertex is actually going to be down 1/2. And my directrix has to go in the opposite direction because my vertex is in the middle. That means it has to be up 1/2. All right, so let's start with my focus. So it's going to be down 1/2, which is going to put me at 9.5. That's right here. That's 4 comma 9.5. And my directrix, which is going to be up a half, my directrix is actually going to be up a half, which is going to put me at 10.5. So y equals 10.5, and then I'll just write it up. So I have my vertex is 410. Focus is 4 comma negative positive 9.5. I think I have negative over here. That should be positive. I'm not sure why I wrote negative. So this is positive 9.5. And my directrix is y is equal to 10.5. Okay, that's it, guys. So have a good night. Make sure you study a little bit. And I'll see you guys in the morning. Have a good night.